Okay, so good day everyone. So for today, we're going to have a Module 3 and Module 4. So data and database management for Module 3. So good business decisions rely on access to accurate data. So to facilitate this, organizations need a system for recording, updating, and tracking data on a regular basis. No? Once collected, data can be retrieved and presented in formats usable to managers and employees of the organizations through a computerized databases. So various database elements can be linked through database management system. So in this module, uh, we shall discuss the basic concept of data, database, and database management system. We will also talk about the functions and components of a database management system. So after, of course, the learning objective, so after completing this course, you should be able to discuss the basic concepts on data, database and database management system, and explain the functions and components of a database and a database management system. Now, data, database, and database management system, we need to understand first what is data. For every database system, the heart of each system is what you call the data. Excuse me. Then, data are facts or figures which we can store in a database. So an example of this is your ID number, the name of your teacher, the number of the students in your class now, and what in that is data. Now, when we say database, a database is a collection of a logically related data, and it is typically visualized as tables, composed of cells matched with several columns and rows. No? And in computer terms, database is a collection of data not necessarily always stored in a computer, such as records stored in a filing cabinet or even in a notebook. Okay, so this time, what is a database management system? A DBMS or database management system is a collection of interrelated data using the software and hardware used to access the data in a useful manner, such as database or set of databases stored in a disk or other media, a computer or set of computers where the software to access the database can run. A DBMS is a software package or software that allows you to store, retrieve, package your database. I just want to show you a video presentations for you to better understand data, database, and database management.
Hello once again, this is Eric Capistrano from UP Diliman, and we will now continue our session on fundamentals of big data and business analytics. At this session, we're looking at now more on the data and database management, because we're going to be going to a lot of the technical details on what data and database management is all about. So first off, we'll be looking at what is data, information, and knowledge management. So data simply refers to raw facts and figures. This can be more like basketball statistics, like how many points, how many rebounds, how many assists did you make. Or, for example, stock market data, like how much you made in one day, what's the volume of transactions, and, for example, maybe even like how many times your teacher swore in class. So just simply data. It doesn't mean anything. So the goal here is to turn that data into information, and we do that by putting that data into several processes. Moving further, so what happens now? So this is now presented in a context where it can answer a question or support a decision making. Now what is important also here is that whatever information that comes out in that technical process should be included there would be the manager's knowledge, his biases, his expertise and experience to further interpret that data and therefore make stronger decisions along the way. One of the most traditional ones that you're seeing right now, and this is the hierarchical structure, where you can see it's literally a hierarchy of data. So this is the early methods and structures, and these records are arranged in a tree-like structure, and the relationships are one-to-many. However, this is not the only structure that we have. So in the next part, we'll be looking at network structure. So this is used in some mainframe packages, if you've been old enough to see what a mainframe is. So in this case, we'll be looking at now many-to-many relationships. So as you can see, it can now become a web of relationships within this database structure. Moving on, we'll be also looking at another database structure, and this is on relational structures, where now we're looking at specific data elements that have relationships with other data elements in other databases. For example, like a student's student number, wherein it's only used not only in registration processes, but it can also be used for, say, your library transactions, or maybe even your dorm transactions. So these are data elements that are stored in different tables, and we can find relationships within data from one file to another file, or one data set to another data set, if both files share common data. We also have another database structure, and this is the more complex one, and this is now the multidimensional structure. Now the multidimensional structure, as you can see, this is now like more of a 3D kind of data. Most of our data that you've seen a while ago are mostly two-axis data, like X and Y. But now we're looking at X, Y, Z, maybe even more. So we use multidimensional structures to organize this data, viewed now being in cubes. And it's not only one cube, not only two, not only three, this can be more. And this is now the more popular database structures that we've seen in a while, and this is now also popular to support any online transactions that are happening now. So we also look into object-oriented structures. Now these object-oriented structures consist of data values describing the attributes of an entity and operations that can be performed on the data. So it's not just about the raw data itself, but it's also about what can be done with this data. What you're seeing right now is a simple banking accounting structure wherein we have one set of data, and then it also tells you what can be done with the data in relation to other files and other databases. So moving on, we now look at data infrastructures now. You've seen how it works individually. Now, how does it look like now in an organizational setting? So for a data management system, you can have two sorts of data that you're seeing right now. First is the data management subsystem, and the other one is the metadata management subsystem. Now, what's the difference? The data management system is basically what I've been talking about. Pieces of data put together, finding relationships, being processed, being analyzed, and so on and so forth. Now, the metadata is simply data about the data. Even before you subject your data to a certain set of analysis, you can already provide certain insights, certain structures, and even certain biases and whatnot, even judgmental analysis on this data. So you can do two things here. It's data and data about the data, which can also give you valuable insights on what is happening. So moving on, we're also looking at examples now of business data infrastructures. For example, we're looking at human resources. So what kind of information can we look at when we look at human resources? Say, for example, you have your name as an employee. You may have your employee ID number. You may have your job title. Also, salary. And then with the salary, you have your social security, your taxes, any benefits, overtime, and so on and so forth. So you're looking at now this structure of data on a per employee basis, and then under each employee will have all of this different data, which obviously have different relationships and different structures with one another. So this is for human resources. Moving on, let's also look at another one. We're looking now at a marketing decision support system. Now, for marketing, it's all about consumer and external data, maybe some environmental data. So we're looking at customer data, we're looking at market data. But on the other hand, we'll be also looking at sales. How much have you made for the month? How much have you made in a year? And we combine all of this different data, subject them to the various processes that you see right now in terms of data management functions, model management functions, and user interface functions. So all of these now are also an example of the combination of different structures that we have seen a while ago. So what else can we see now as an example of business data infrastructure? We're looking at banking customer management system. So in this case, like say I'm a customer of a bank. I make an inquiry, and based on the inquiries, then the bank can tell what kind of services that I want, what kind of products that I want. Do I want a checking account? Do I want a savings account? Do I want to get a loan? Do I want to get a credit card? So all of these different transactions have their own databases, and they're also subject to some processes in terms of transaction processing and database management, and all of these are collated into a customer database for us to use. So again, all of these examples that we've been seeing right now are just not an example or a combination of examples from these different database structures that I've shown you a while ago. Big data infrastructures now. So how do we blow this one up? So what I've shown you a while ago are mostly more on the current transactional small-time pieces of data, structures, database management, infrastructures, and so on and so forth. However, for big data infrastructures, what you can see is that this has become more complex. It's a combination of different structures, different methods, different applications, and even different ways of looking at processes and relationships. I'm not going to go into detail of this because it's going to take us the whole day for us to do this, but as you can see, the impression there is that big data infrastructures are the more complex and the literally bigger infrastructures that we see right now. We also look at another example. So this is another example just to give you another more emphasis and more impressions on how complex big data infrastructures are. As you can see, this is one of the big data advanced analytics infrastructures that IBM is currently employing. The point here is that as we can see, we have a multitude of different infrastructures that is needed for us to run big data. So lastly, so we look at data resource management. So this is the part wherein, after talking about all of the different infrastructures, how do we manage it? How do we take control of it? So we look at data administration, data planning, and data administration at the lowest level. So we're starting off. So data administration at the highest aspect will be to develop and enforce policies and practices. This is very important. You have seen how complex these data infrastructures are. So obviously, we would need some policies, we would need some rules and regulations for us to do our work as far as analyzing, even collecting the data is concerned. Now, for data planning, we're looking at mostly at the mid-tier one, like the middle management one, wherein we set and enforce our all of these protocols, all of these policies, all of these practices that we've planned out for. And lastly, for the data administration, this is the part wherein we do conduct now the design processes, we execute those processes all in all. So this is how it's going to look at the end. So what you see now, the yellow part on the data administration, this is on the strategic aspects. The data planning is on the tactical aspects, and the data administration, the green one below, are more on the operational day-to-day. So this is how we can work when it comes to managing all of these big, complex data infrastructures. Now for the details of this, one, that will be up for our next session, which is on business information, business applications, and even issues and challenges that are facing our management structure.
Okay, so this time we're going to discuss about the functions of a database management system. So what are the functions of a DBMS? No? What are the advantages of using a DBMS? Here are some of the functions of the DBMS. No? The DBMS can provide a convenient and efficient interface for, again, storing, retrieving, and updating data. And of course, for extracting useful information from database and a clear and logical view of the process that manipulates the data. Number one, of course, is the data independence, because database management system maintains the segregation between the program and the data. Number two, concurrency control. This refers to a process to ensure that data is updated correctly and appropriately when more than one person is accessing the data. Number three, recovery services. This refers to a mechanisms for recovery of data that is apparently lost due to system crashes. Number four is utility services. An initialization and maintenance operations on the database. Number five is the manipulation of data. It tells us that we can create. CRUD stands for create, retrieve, update, and delete our data within the DBMS. Number six is a database definition. Metadata describe the contents of your database. And this is the data that describes another data in terms of its constraints, size, and the data type of the tables or the databases that are contained with your database management system. Number seven, data processing. This allows the user to perform different types of operations such as string manipulations, date operations, and so on. And you can also manipulate the database on an event or what they call triggers, which is based on the event or the conditions of the event. Number eight, of course, is data sharing. No? This means that within a database, privileges are provided to different types of users. Different type of users can access the same database, but the same users can have different privileges. Next will be the components of the database management system or the database system itself. Number one is users. The users of a database system are the database administrator, system developer, and of course, end user. A database administrator, or the DBA, is the person responsible for all of the data resources in an organization. The database administrator uses tools that come with a database management system to improve the productivity and performance of database planning and design. So, the system developers are those groups of people who create the application programs that cater to the user requirements. And they use their own tools to write programs that communicate with the database management system. Finally, the end users in an organization are the ones that can add, update, and delete data in a database through application programs or directly, actually, through a database management system. Excuse me. They use the application program to accomplish their day-to-day task. Number two is the database application. This will be the next component of a database system, is the database application. And this is a computer program that allows users to manipulate the data in a DBMS through a user-friendly interface. It can be divided into 4 broad categories. Personal, which is restricted to a single user. Departmental, which is referenced by hundreds of users over a shared system or network. Enterprise, which extensions of a departmental applications involving thousands of users in the internet, no? Which is the largest form of information sharing where billions of users are involved. Number 3 is the DBMS, or the Database Management System. Again, as what we mentioned earlier, the Database Management System decouples application programs from data. And the databases store all its data in one location, thereby limiting data duplication. Example of database management system includes Microsoft Access, no? Oracle, no, which is the most commonly used right now, Oracle, no, IBM's DB2, SQL Server, and others, no. When it comes to database, we defined it already a while ago, and even our video presentation no discuss about the database, because the final component of a database system is the database itself. This is the space in the disk or computer where the data are actually stored. Then, of course, another is the interface. The interface is responsible for interacting with the user. It is also called the middleman, as it communicates between two different parties. So the end user, which is you and me, and the database management systems. So the interface allows the end users to input values that will be understood by the database management system. It is also responsible for the receiving and outputting and providing the results of the queries or the commands that the end user issued. Another, of course, is the parser. So the parser is responsible for checking the correctness of the syntax that was provided by the end user through the interface. So it also checks the tables and other objects in the query. Next, of course, will be query optimizer. If the parsing is correct and proper, then it will proceed to what we call the query optimizer. The query optimizer comes from the root word optimize, which means it simplifies the query form or the input into a simpler type of input that can be digested and can be understood by the database management system. And this allows the database management system to save time, save space when performing operations. Next will be the execution engine. No? The next, of course, the next one is the execution engine, as I mentioned. Its main responsibility is to execute the output of the query optimizer. So, once the query has been optimized, then it will pass the data or the optimized query to the execution engine whose sole purpose is to execute the command. No? And the last one is the storage. The storage is the physical location of your database, which can be the secondary or the primary memory. Of course, we need to accept the fact that at present we are using, of course, a server. No, we have a, of course, right now we're adopting also the cloud computing, no, and so on. So I just want again to give you a video presentation, no, wherein you could able to have an additional perspective of what I have mentioned earlier. But before I forget, if you have some additional inputs, do not hesitate to type or encode your inputs or comments or questions in our chat box so I could able to address all those questions as soon as possible.
A pleasant day to everyone, and welcome to this course in Database Management Systems. I'm Assistant Professor Reginald Neil Recario from the Institute of Computer Science, University of the Philippines, Los Baños. For today, we will be talking about the following. We will be discussing about data, database, database systems, and functions and components of what we call the Database Management System, or DBMS. And then it will be followed by database normalization, entity relationship diagram, and relational modeling. Now, we start with defining what is data, because in every database systems, the heart of each system is what we call the data. Now, essentially, data are just facts that we store in our database. So it can be details of a person, say for example, a name, a home, address, etc. So these are details, these are variables that we are concerned with in a specific problem domain or a specific domain. Now, a database, in contrast, is a collection of logically related data. And it is typically visualized as tables, meaning to say it is composed of cells, and the cells are matched with several columns and rows. And then for each of the columns, you have there what we call the column headers, describing what is the content of that particular column, while the rows represent some data or some instance of that particular table. So for example, we have here a table of a student containing the columns name, the degree program, and age. And say for example, we are listing here a database of, or a table of, or student records. We have here Maria Makiling, Pedro Pinduco, and Juan Makata. These are the names of the students together with their degree programs. We have BS Computer Science up to BA Communication Arts. So as you can see here, each column represents the attribute or the column representing the characteristic or the data that we are concerned with, in this case for the student. And then each row represents the student per se. And each student here contains the following attributes. We have the name, degree program, and age. We will now discuss what a database system is, but before we continue, we will first discuss what a database management system is. A database management system is a software package or a software that allows you to store, retrieve, manage your database. So essentially, these are the popular database management tools or software that we are currently using in the industry. Say, for example, MySQL or MySQL, Postgre, and Oracle. Now, a database system, in this case, is simply the combination of your database and your database management system used by specific industries. Say, for example, the airlines industry, healthcare, say, for example, for student records. So those are already database systems. So we will be discussing here the functions and the components of a database management system. There are a lot of functions for a DBMS or a database management system. We will be discussing 4 of them, which is the following: the manipulating of data, the definition of your database, the processing of your data, and then the sharing of your data. Manipulation of data is one of the crucial and basic or fundamental functions of a database management system. It just tells us that we can actually perform a create, retrieve, update, and delete of our data within the database management system. We call it CRUD, C-R-U-D. Okay? And then defining the database or the definition of the database, there's what we call a metadata, which describes the contents of your database. So this is a data that describes another data. So it might be concerned about the constraints, the size, and the data type of the tables or the databases that are contained within your DBMS. So say, for example, if we have a student table having 3 columns, the name, the age, and say, for example, the birthday, you can probably put a constraint on the age wherein the age should not be greater than 100 because we have short life expectancy, or we don't actually expect everyone to be having an age more than, say, for example, 100 or probably 200 years old. Or probably a constraint on the type. Say, for example, on the name, it's a string or it's a set of characters. Okay? So it's a data type of the name column. The next is processing of data, which is it allows you to perform various operations, or it allows you to perform different types of operations. A lot of DBMS right now supports a variety and plethora of different operations. So you can perform string manipulation, date operations, and so on. And then you can also manipulate the data based on an event. This is what they call triggers. So say, for example, if you own an account within a certain banking institution, and say, for example, that particular banking institution does not allow withdrawal from your account based on the amount that you have already deposited. Say, for example, there's a minimum of 500 peso that needs to be retained in your account. Then if, say, for example, you tried to withdraw from your account and it's already 500 pesos, then the system can already prevent you from withdrawing even without the programmer or the developer invoking a command to prevent you from doing that. So that is what we call a trigger. So it is based on the event or the conditions of the event. So in this case, the event is triggered by the condition that your account is already been below the maintaining balance or the required amount that needs to be maintained in that particular account. The next is sharing data. It means that within a database, you're actually provided of several privileges to different types of users. Now, several types of users can access the same database, but the catch here is that these particular users have different privileges. So say, for example, in a university records database, it's possible for a student to access the database. However, the student can only perform viewing of his or her account, and then probably viewing the available slots and available subjects within the course or within a particular semester. Now, in the same database or in the same set of records, an instructor can see a different set of values. Say, for example, the instructor can view the set of students that are assigned to his or her class, and an instructor can probably add students within his or her class, and an administrator may have a different view as well of the data. So this particular privileges given to the database allows us to ensure that there is security within the database. So that is one related function of the database, that it allows us to provide access to our data that is secured. Speaking of the components of your DBMS, we have the following components, and this is already simplified. If you have several references, you might observe that this particular framework or this particular diagram is already simplified. So we have here the interface, the parser, the query optimizer, the execution engine, and then the storage. And we will be discussing them one by one. The interface is responsible for interacting with the user. So essentially, I call it the middleman because it communicates between two different parties. The end user, which is you, and the database management system. So what it does is that it allows the end user to input values that are understood, that will be understood by the database management system. And the interface is also responsible for receiving and outputting, providing the results of the queries or the commands that the end user issued. So whether or not the command failed and what particular errors were committed if the command failed. The next one is the parser, and the parser is responsible for checking the correctness of the syntax that was provided by the end user through the interface. So it also checks the tables and other objects in the query. So say for example, if the user wanted to get the list of students in a student's records, the parser will determine whether or not the name of the columns were correct, and the parser will also determine whether or not the name of the table is correct, and it will also determine whether or not the whole command or the whole query is correct based on the syntax or form of the input. Now, if it happens that the parsing fails, then an error will be shown to the user through the interface. Now, if the parsing is correct and proper, then we will proceed to what we call the query optimizer. So the query optimizer, from that root word optimize, so we have there the term optimize or optimizer. So we have optimize, meaning to say it simplifies the query form or the input into a simpler type of input that can be digested and can be understood by the database management system. This allows the DBMS to save time and save space when performing operations. So if you are performing a very complicated operation or command, and the query optimizer found out that, hey, I found a very simple command that is similar to what you have provided, then it will perform that particular command that is far simpler so that it can save space and time. Okay? Now, the query optimizer does this through a lot of mathematical transformations, which we will not be discussing in this course. The next one is the execution engine. So its main responsibility is to execute the output of the query optimizer. Once the query has been optimized, then it will pass the data or the optimized query to the execution engine, whose sole purpose is to execute the command. So how this particular component or module does this is just to retrieve the contents specified based on the query provided in the storage, which is the physical location of your database. So it might be residing currently in the secondary or in the primary memory. So typically, you are actually accessing it in the secondary memory. So it finds out whether or not the data that you are looking for is in the storage. So if it does, then it will collect those particular information or those particular data, and then it will be passed back to the execution engine, back to the interface. We will now be proceeding to what we call database normalization, and this is one of the important activities being done when you are designing a database. Database normalization, or simply normalization, is the process wherein you actually prevent or reduce or remove redundancy in your data. Redundancy is not good because it allows you to have problems within your database. We call it anomalies, and there are different types of anomalies, and again, we will not be covering them here. But another important matter about normalization is that it also ensures integrity. That whenever you change, you update your data, it ensures that the update was done correctly, and that whenever you check your database, you are certain or you are sure that it is in the correct state. Meaning to say, the values that you are seeing there are already correct. There are different types of normalization or different forms of normalization. We call it normal forms or NF. And we have listed them here. We have listed a few of them here. We have 1NF, 2NF, 3NF, BCNF, or the Boyce Code normal form. But there is a lot more normal forms provided. But we will just focus on the first three, which is the first normal form, second normal form, and the third normal form. Now, something to note of, the normal forms are achieved by satisfying the previous normal form. So what I'm trying to point here is that you cannot achieve the third normal form without passing through the second normal form and the first normal form. So the analogy that I use here typically is a house, a storage building with no elevators. So the idea is that you have to walk through stairs, and if you want to achieve the third floor, or if you want to go to the third floor, you need to pass to the second floor. And if you want to go to the second floor, you need to pass the first floor. So essentially, if you want to go to the fourth normal form, you need to satisfy the third normal form, the second, and then the first. So that's the idea. So let's start. We have here the first normal form, or the 1NF. The idea in the first normal form is that all the attributes within the relation or the table must be atomic, meaning to say the attribute is already in its simplest form, and it should be single-valued, meaning to say the attribute must be assuming one value at a time. Now, the idea is that for each of the multi-valued attribute present, they must be separated together with the key of the relation. You're going to perform this operation for every relation within the database. Let us start with an example for the first normal form. We have here a student relation which has the following attributes: the student number, the name, the contact number, and the email address. Now, for this particular example, we will assume that the student number and the name obviously does not contain multiple values. And then for the contact number and the email address, it's possible for us to have multiple values at the same time. So say, for example, you have three contact numbers for the contact number attribute or column, and then several email addresses for the email address attribute or column. Now, in this case, we have here a relation which has both simple and multi-valued attributes. Simple attributes were the student number and the name, because they can only assume one value at a time. Whereas the contact number and the email address can contain more than one value at a time. So in this case, this particular relation violates the first normal form. And in order to satisfy the requirements of the first normal form, what we need to do is to separate or to segregate the multi-valued attributes. In this case, the contact number and the email address. And thus, we will be able to create three tables or three relations. We have the student. The student relation contains only the student number, which is the key attribute of the relation, and then the name. And then another relation would be the student contact or the student contact number, containing the student number and then the contact number of the student. As mentioned before, contact number is a multi-valued attribute. Thus, it was separated from the student number and name. The same is true for the student email address, wherein we separated the email address, we put the email address in a separate table together with the student number. And if you can observe, the student number for both the student contact and student email address were also underlined. So, because the student number is a key attribute from the original table. And how about the contact number and the email address? They were also underlined, simply because the combination of the student number and the contact number within the student contact relation makes the combination unique. Since we know that the student number matched for every contact number will be repeating, then the key attribute student number will not be able to identify or uniquely identify the contact number. So in this case, the combination of the student number and the contact number makes the instance of a particular student contact relation unique. The same idea applies with the student email address. So you can see there that the student number and the email address were both underlined because their combination makes the instance unique. However, that is not true with student. So it means that the student number is already enough to identify the instance of the student. There's no need to underline the name of the student. Now, in the case of name, if you insist that name is also not conforming with the characteristics or the definition of first normal form, because we mentioned there, we emphasized purely on the multivalued attributes, but you can also put there the idea of atomicity, meaning to say it should be atomic. And if you insist that name is not atomic per se because it is composed by the last name, first name, and middle name, then you can just decompose the name into several components. So the last name, the middle name, the first name, and you can also include the suffix or the suffix, junior, senior, the fourth, the fifth, the second. The next one is the second normal form, or 2NF. The idea or the main idea for the second normal form is what we call the functional dependency. So in second normal form, or 2NF, it must first satisfy the first normal form, definitely. And the attributes of a table or relation must all depend on all the keys of the relation. So the basic principle here is what we call the full functional dependency, or full FD. Now, I'll just be giving you a crash course or side discussion on functional dependency. A functional dependency is defined as this particular expression, x arrow y. It is typically read as x functionally determines y. It divides your attributes within a relation into two sets, the x and the y, and x determines the value or the values of the y attributes. The value or how you choose your x and how you choose your y depends on the context of the domain, meaning to say it's domain specific. And for cases wherein the database designers, administrators, or developers are not able to define which attributes belong to the x component, x set, or which particular attributes belong to the y set, it depends on some domain experts that you need to consult. So this is particularly resolved during your analysis and specifications, wherein you consult different domain experts, you consult with the end users, you consult with the client, and you consult various people who are more knowledgeable with the background why a particular system was developed. Now, we proceed with the example provided. So say, for example, we go back to the student relation. We have here batch year, the number, the name of the student, and then expected year of graduation. And we make the following assumptions. The batch year is the year of entry of the student. So say, for example, 2014 or 2017 or any year for that matter. And the number is a 5-digit number representing his number within that particular batch. And then we make the following other assumptions, that the batch year and the number combined is the student number, and that the expected year of graduation can be computed through the batch year. So you just add 4 years. Okay? We assume here that all the courses for this particular student list, they all graduate after 4 years. Now, the functional dependencies provided or generated would be the following. The first one would be the batch year, and the number would functionally determine the name. So it means that the combination of the batch year and the number, when you combine them, you can determine the name of the student, which is true because that is the student number of the student. Now, in the same manner, the batch year can also functionally determine the expected year of graduation because you just need to add 4. And given the batch year, you can just compute the value for the expected year of graduation. There's no need for you to give the name. At the very least, you need the batch year. So those are the functional dependencies that we can actually extract from the given example and assumptions. Now, notice here that within the student relation, we stated for the second normal form that all the attributes must depend on all the keys. So in this case, we can find an example that violates that rule, which is the expected year of graduation. Why is that? As you can see here in the example, the batch year and the number are both underlined, meaning to say they are keys of the relation. And if they are keys of the relation, it means that they are able to identify an instance of the student. The combination of those values can determine a particular student. Unfortunately, the expected year of graduation only depends on the batch year. And as you can see here, it should be dependent on both the batch year and the number. That is why the expected year of graduation violates the rule or the definition of second normal form. So in this case, in order for it to satisfy or to resolve, in order for us to resolve the problem, we will decompose the relation. Meaning to say, we will again divide the table into two. So that is the student table or relation containing only the batch year, the number, and the name. And the expected year of graduation was separated into another table. We call it student underscore expected grad or X grad, containing the batch year and, of course, the expected year of graduation. The batch year was included simply because the expected year of graduation depends on the batch year. And the batch year also determines its value. So as you can see here, it's also underlined. We now move on to third normal form, which is last of the three normal forms that we will be discussing here. Again, the requirement for the third normal form or 3NF is that it must satisfy the second normal form. The idea or the principle behind the third normal form is what we call the transitive functional dependency. And the idea is that you should not be able to find transitive functional dependency within the same relation. So if you have X functionally determines Y and Y functionally determines Z within the same relation, then that should not be allowed or that should not be possible, because that also implies X functionally determines Z. So the idea again is that the attributes within the relation must depend only on a key. So as an example, we have again the student relation containing the following attributes: the student number, the name, the units earned, and then the standing. And we have the following assumptions indicated. So the units earned is the number of units earned or taken and passed by the student. And the standing refers to whether or not the student is a freshman, a sophomore, or a junior. Now, given this relation, we can extract or determine these functional dependencies. The student number functionally determines the name, the units earned, and the standing. And in the same relation, we can also determine this functional dependency. The units earned functionally determines the standing. So say for example, if you have earned 60 units of a particular degree program, then you might be classified as a sophomore. So around that value would make you a sophomore student according to a specified classification. So in this case, we can see here that the student number also determines the standing, which is already indicated. But whether or not the standing is included in the first functional dependency, the violation would still persist. Meaning to say, through this particular transitive functional dependency, we can find that the student number functionally determines the units earned. The units earned functionally determines the standing, and the student number would functionally determine the standing. So that is already a violation of the third normal form, or the characteristic or the rule for the third normal form. And again, in order to resolve this, we will again decompose the relation into two. We will separate the attribute that causes the problem. In this case, the standing. So we will now produce two relations containing the following. We have student having the student number, the name, the units earned as its attributes. And then the student standing would comprise the units earned and the standing. Now, notice that for the student, you have there the student number as the key attribute of the relation, which is rightfully so in the first place. And for the student standing, the key attribute is the units earned, because the standing depends on the units earned. We will now be moving on to entity relationship diagram and relational modeling, which is the last part of the discussion. Now, before I continue, I will just be having a crash course or a side discussion on models. So models represent some systems that you want to describe. It is composed of notations that you will be using in order to communicate with your users or with some people or with people who will be using the model. And then the models are governed by rules and probably some exceptions to the rules that are universal or that are accepted for that particular model. And then, of course, it is also composed of behaviors or processes that are expected within that particular model. So, in that matter, we will be discussing, or we will be now moving on to relational model, which is one of the important models, one of the earlier models, and one of the most popular models being used whenever you design a database. So a relational model, by definition, a relation or a table is composed of columns and rows. The columns are composed of attributes, which I think have been mentioned repeatedly throughout this particular session. And then it is also composed of rows, meaning to say a record or an instance of a particular table. So we will be using this example again, the student relation or student table containing the attributes name, degree program, and age. And for each of the column, you can see there that it has values. So for the name, you have Maria Makiling, Pedro Penduko, and Juan Makata. Now, the columns describe what particular attributes are being contained for a specific relation, whereas the rows represent the instance of the relation. So say for example, your relation is a student, Maria Makiling is an instance of that particular student. So Maria Makiling has a degree program of BS Computer Science with an age of 15. Another model related to relational model is the entity relationship model. So this is also another popular model being used when you design a database. So it's a high-level conceptual model, meaning to say it's a model being used to convey or to simplify ideas communicated to various humans. So the representation is very much simplified in order to capture the basic processes. And the idea is that it describes the data as entities having attributes, and each of the entity has their own relationships with other entities. So you need to only remember three concepts at this point for entity relationship model. You have the entity describing the relation or a specific object. You have the attributes, which are the characteristics of a particular entity. And then, of course, the relationship, which is relationships of different entities. The entity relationship diagram is a diagrammatic notation being used for modeling your ER models. And there's these two popular notations being used, the Chen's notation and the Crowfoot notation. In this particular session or discussion, we will be focusing on the Chen's notation. The Chen's notation is composed of these symbols and their descriptions. And as you can see here, there's a number of them. But instead of discussing them individually, we will be using them in a problem as shown here. So an employee is assigned to a room in the company, and an employee has a name, birthday, salary grade, and an employee number, which is unique. And a room has a room number, room size, room capacity, and room location. The room number can identify the room, and you have their additional information about the relationship of the employees and the room. A number of employees can be assigned to a room, and an employee must be assigned to a room, but a room is not required to be assigned with an employee. And lastly, an employee can be assigned to only one room. So given this particular information, how will you be able to use the ERD in order to model this particular problem? Now, I'm going to show you the answer for that problem and explain to you how we were able to derive this particular drawing or this diagram. So we have here the employee and the room. They are both entities of the problem or of the given example. So as you can see here, employees and rooms, they have attributes. So that is why they are the entities of the problem. Entities are typically nouns, or they are nouns in the problem, and the employee and the room entity, they are written here in singular form. And in fact, all entities are written in their singular form. Okay? Now notice that for the employee and the room, they are surrounded by several ovals there. We call it attributes, and they are the one describing the entity. For the employee, we have there the name, the birthday, the employee number, and the salary grade. And for the room, you have the attributes, room size, capacity, location, and then the room number. So those are the attributes of the room. Now, of course, we know that the employee and the room, in reality, they have a lot of attributes. But considering the example, we will be just focusing on those attributes. Now, as you can see here, is assigned is a verb that relates or provides a relationship between the employee and the room. And is assigned is represented by a diamond shape used in the notation for chance. Also included here, some of the things that you have to take note of is that the is assigned text or verb is written in capital form or capital letters. So that is also a requirement for chance notation, that the verbs are written in capital letters, which is also true for the nouns or for the entities. However, that is not true for the attributes. And if you can see in the example or in the answer, you can see there that the first letter is capitalized and the succeeding letters are written in lowercase letters. Okay? And they are surrounded by, or they are put inside an oval. And these ovals are connected by a line to their respective entities. The same is true for the relationship is assigned. So the is assigned relationship connects the employee and the room. You might have noticed that there is a letter N and number 1 beside the employee and the room respectively. Now, before I continue explaining why there's a letter N and a number 1 and why there's a double line connecting the employee to is assigned relationship and there's only one line connecting the room to the is assigned relationship, we will be discussing the cardinalities. Now, cardinalities is one of the constraints imposed in an ERD. There are 4 constraints available or being provided. The first one is the cardinality or cardinalities. The second one is the participation. The third one is the completeness. And then the fourth one is the disjointness. Now, the first one is cardinality, which we will be focusing here together with the participation. Cardinality is concerned with how many instances of an entity is mapped with another entity via a given relationship. So as you can see here, there are 2 entities, the employee and the room entities, and they are related via the is assigned relationship. So the question here is that how many employees or how many instance of an employee is mapped out with a room. And from the room's perspective or side, how many rooms would be there to assign a particular employee. So in this case, we will be introducing you the 4 basic cardinalities, one-to-one cardinality, wherein an instance of an entity is mapped out to another instance of another entity. So there's a one-to-one correspondence from an entity in the left and one entity in the right. Another one is the many-to-many relationship or the many-to-many cardinality, wherein an instance of an entity in the left can be mapped out to many instances of an entity in the right. And the same goes with the entity in the right. They can be mapped out to many instances of the entity in the left. Now, we also have what we call the one-to-many relationship and many-to-one relationship. one-to-many, meaning to say one entity in the left side, or the instance of the entity in the left side is mapped out to many instances of the entity in the right side, whereas many-to-one is just the opposite of one-to-many, meaning to say the many instances of the entity in the left is mapped out to one entity or one instance of an entity in the right. So as you can see here in our example, this one is an example of what we call the many-to-one relationship. So it means that many instances of the employee is mapped out to a particular room or to a single room. So it means that, say for example, if I'm an employee and I am assigned to a specific room, say for example room 1, then I can no longer be assigned to room 2. And room 1 can get or can assume a lot of employees, but once an employee is assigned to that particular room, room 1, they can no longer be assigned to other rooms. So that's the idea of many-to-one relationship. If it's one-to-one, then it means that an employee assigned to a particular room can no longer be assigned to other rooms. So it means that if I'm assigned to room 1, then I'm only mapped to room 1, and I can no longer be assigned to other rooms. So we have a one-to-one correspondence of room 1 and me being the employee. Now, another problem or another constraint here is the participation constraint, denoted by the lines connecting the relationship and connecting the entity. So as you can see there, in the side of the room entity, we have there a single line, whereas in the side of the employee entity, there is a double line. The double line is what we call the total participation, and the single line is what we call a partial participation. When we say partial participation, it means that the room is not required to exist in the relationship, whereas the employee entity is required to exist in the relationship, or is dependent on the relationship, or is dependent on the entity via a given relationship. So what I'm trying to point here is that the existence of the employee is dependent on the room, whereas the room is not dependent on the employee. Now, to illustrate, let's go back to the statement provided. As you can see there, a number of employees can be assigned to a room, and an employee must be assigned to a room, but a room is not required to be assigned with an employer. So given that statement, you can already get an idea that the room can exist in the given relationship without the employee. But in order for employee to exist, there must be a room, or it is dependent on a room. So that's the idea of total participation and partial participation. So in this case, the employee is of total participation with the is assigned relationship, or with the room via the is assigned relationship, whereas the room is of partial participation with employee. So its existence is not dependent on the employee. Now, with those information, basic information, you can now create your ERD. Some note, you might have noticed also that there's an underline for the employee number and the room number. We call them key attributes. And key attributes are important because they define, or they allow us to pinpoint a specific instance of an employee and a room. So in this case, for the employee, you have there a key attribute, employee number, and for the room number, for the room, we have there the room number as its key attribute. So given the employee number, you can determine a specific employee, and given a room number, you can determine a specific room. So that's the idea of the key attribute. Key attributes are underlined so that you can determine or know by just looking at the notation or just looking at the diagram that they are the key attributes of a given problem. Now let's proceed to the second and actually the last example in this particular set. Kindly read this long statement. I'll be giving you time to read it. And assuming that you have read and you probably have skimmed this particular long text, I'm not quite sure if you will be able to arrive to this particular drawing because we have not yet introduced some things there. Okay? But for the most part, you might have if you have tried this particular problem, you might have arrived at a similar drawing or a similar diagram, but some of the items might be incorrect. Now, I will just be focusing on those items that you might have gotten incorrectly. As you can see there, the dependent entity is drawn using two rectangles. And you also have there a relationship has, also drawn with two diamonds. Now, earlier I told you that we have here entities that contain what we call key attributes, and they are underlined. Unfortunately, for dependent, in the given example, you can't find there an entity or an attribute rather that has an underline. Dependent here is an example of what we call a weak entity, and employee here is an example of a strong entity. A strong entity is an entity that has a key attribute. So in short, if you can see something there, an attribute there that is underlined, it means that the entity is strong. Whereas if you cannot find an attribute that is underlined, it means that the entity is weak. So the employee here is a strong entity because it has employee number, a key attribute, whereas the dependent entity doesn't have any attributes that is underlined. So in short, it is a weak entity. Now, in the absence of your key attribute, there's what we call a partial key, which is an attribute that can potentially identify the dependent. So in this case, that is name. And the notation used for partial keys would be the use of still underlining the attribute. But this time, if you can see in the problem or in the diagram, it's a broken line. So the broken line is the notation used for signifying that an attribute is a partial key. Now, a partial key, as I've mentioned, it's not able to completely determine the instance of dependent. So it can potentially determine the dependent. It still depends on another attribute. And in this case, it depends on the employee number, to which it has a relationship via the relationship has. And in this case, the has relationship is what we call the identifying relationship, because the dependent depends on the employee in order for the instance of dependent to be identified. So as we know, name is not a key attribute here because a lot of people out there have similar names. And in order for you to pinpoint what specific person you are referring to, or if you want to determine who specifically is the dependent you are talking with or talking to, then you need to get the name and the employee number of that employee in order to secure or to pinpoint a specific instance of that dependent. So that's the idea between the use of the partial key and the key attributes. The partial key cannot completely determine the existence or the exact existence of a particular dependent, or in this case, particular entity. Whereas the employee number or the key attribute can uniquely identify the employee. Okay? So those are the examples provided here. I hope we were able to clarify things up. And thank you for listening to this discussion.
Okay, so actually this will be a much detailed discussions of the data, database, and database management with, of course, and the most important is the normalization. No? Okay, so this will be another video presentations actually, wherein you could able also to have an additional or other perspective when it comes to data, database, and database management system. Because again, as I mentioned during our first meeting, it is important for us to learn on how to understand different perspective, different examples, and different way of discussing the specific topics, no, or modules. No? So
A pleasant day to everyone, and welcome to this course in Database Management Systems. I'm Assistant Professor Reginald Neil Recario from the Institute of Computer Science, University of the Philippines, Los Baños. For today, we will be talking about the following. We will be discussing about data.
Okay, so before I forgot, this will be the references for the data, database, and database management. So I wasn't able to attach the second video actually. And I double I'll just attach all again the other one, the video that we already presented earlier. So this time we're going to have a discussions about application of business intelligence, or the business analytics rather. Okay, so in module 1, we discuss how data becomes business value. We learn that raw data needs to be extracted from its sources, cleansed, curated, and warehoused to prepare it for analysis. And this data can be analyzed in different ways depending on the problem or situation at hand. They can be leveraged in various ways to optimize business operations. In this module, that is module number 4, we will review the 3 types of commonly used analytics: descriptive, predictive, and prescriptive. Actually, we shall also give example of applications for business analytics, especially in the 3 functions which are mostly present in the industry, like finance, human resource, and marketing. Actually, we already discussed these 3, but I just want to reiterate more. Okay, so let's review the 3 types of analytics, because we already discussed this one in our module number 2. Descriptive, as a data-driven benchmarking, and this is the data that is used to benchmark and to profile to be able to establish historical trends. It is the commonly used analytics by companies. Now, going back to the example in this video on how Waze works, understanding how the traffic is today, or how bad the traffic is in a certain location, that's descriptive analytics. Here, you're not making any predictions nor looking for any relationship yet, just looking at data as it is. The next one is the predictive, data-driven prediction. Now that we already know how the data looks like, we can now understand the relationship in the data. So once we know the relationship inside the data, we data into the predictive model. Now let us go back to the example on how Waze works. Since we already have information on the destination and the time of departure, Waze will estimate the time of arrival and predict how long it will take for us to travel. Waze will estimate the time of arrival, and this is prescriptive analytics. Another is prescriptive, data-driven recommendation. So the 3rd type of analytics is the prescriptive analytics, because it involves providing advice on what actions can be taken given the predictions about the future and what drives the future. So to explain this further, let's go back to the example in the video on how Waze works. If you want to know what the 3 best routes are, let's say, for example, between Quezon City and Makati, Waze can suggest the top 3 routes. So the decision is up to you to choose which you think is the best route. And that's the essence of prescriptive analysis, knowing the cost and benefits of a decision. Now, application of business analytics in finance. Now that we are familiar with the types of analytics, let us look at the applications of business analytics in finance industry. An example of descriptive analytics in finance is using analytics in reporting financial results from gathering financial inputs from different sources, cleansing it to reporting it. No? Predictive analysis, on the other hand, is when we want to predict the trend of sales for the next 2 months using historical patterns of seasonality and examining whether investment or investing a lot in salespeople might also drive the sales trend. Prescriptive analysis is also actually applied when we want to determine the feasibility of the project. Say, the likelihood that the project will falter or overshoot the budget or fail. And this is with the assumptions that we have looked into considerations the various inputs such as cost of materials, location of project, and others. Next will be the application of business analytics in human resources. Now, again, analytics plays an important role in human resources. Suppose you are an HR manager and you want to understand demographics of the employees in your company. So you may need information on the diversity of the employee's location, address, school graduated, and others. And this is where descriptive analytics can be used to manage human resources better. As an HR manager, you may also want to determine which employees are likely to resign because recruiting new people will mean additional cost for the company. You may use predictive analysis in this case by looking at the historical patterns of resignation to determine the likely causes of resignation and the number of employees that are likely to resign in the future. And finally, as a human resource manager, you may also want to determine the drivers that make employees stay in your organization. Employee engagement, such as looking at what makes them content, happy, and stay in the organization, like party, bonus, pre-training, and others, is where prescriptive analysis can be used. Now, application for business analytics in marketing. So, marketing analytics is very useful, especially if you are in the marketing industry. Let's say, you are in charge of monitoring the results of an online marketing and sales campaign in your organization. So you can use descriptive analytics to determine how many people click the ads and how many people bought the product, how many people paid cash on delivery or by credit card. So if you want to understand how factors like price, marketing mix, and attributing the effect, channels, mode of payment, and others contribute to the performance to predict the future performance or the success or even failure actually of a campaign or do achieve targets, you can use predictive analytics. On the other hand, prescriptive analytics in marketing can be seen through the recommendation engines which are found to be successful in driving more sales. And these are the recommendations that you can see whenever you visit in an online shopping website, say to buy a book. This recommendation will go something like those who bought that book also bought this book. And these recommendations is based on the prescriptive algorithms which look on the patterns of people who buy the same product or profiles that look similar or items that are purchased together. So, this time, of course, I just want to show you a video presentations of what I have mentioned earlier. Or
Welcome to the lesson. Today we will understand the various applications for business analytics. In this lesson, we will review how data becomes business value and the 3 different types of analytics. Then we will look at various applications from an industry perspective. How does finance use the 3 types of analytics? How does human resources use the 3 types of analytics? And how does marketing use the 3 types of analytics? These 3 functions, the finance function, the human resource function, and the marketing function, are present in almost every company. How does data become business value? It helps to understand that raw data in itself is not really useful. It has to pass through a process. First, raw data needs to be extracted from its sources. Once the raw data is extracted, it is cleansed, curated, and warehoused, at which point it is now prepared for analysis. Then, insight is generated from this stored data using descriptive, predictive, and prescriptive analysis, and at which point a business action can then be taken on the recommendation. So this process of transforming data to business value starts from a raw data, turned into insight, and then turned into action, at which point a company or an institution can benefit from the results of the analysis. There are 3 general types of analytics. The first type of analytics is descriptive. This is data that's used to benchmark and to profile. You're not really making any predictions yet. You're not really looking for any relationships yet. You're just looking at data as it is to tell you how things are at the moment. The second type of analytics is predictive. You already know how the data looks like. Now you want to understand what are the relationships inside the data. And once you've understood the relationships, you can now make predictions and forecasts by feeding new data into that predictive model. The third type of analytics is prescriptive. Once you have a predictive model, you can feed new inputs into that model and simulate outcomes. Once you've simulated outcomes, you can now select which is the best outcome for a particular decision. To understand the 3 types of analytics better, it always helps to understand how Waze works. Waze, as an app, is an example of the 3 types of analytics. For example, if you wanted to understand how the traffic is today, that's descriptive analysis. You're not really predicting anything yet. You don't have a destination yet. You just want to look at how bad the traffic is on the next corner. If you already have a destination and a time of departure, Waze will actually predict how long it will take for you to travel. Depending on historical travel patterns, depending on your historical travel patterns, depending on how the traffic is today, Waze will estimate the time of arrival. The most popular use of Waze is prescriptive. If you already know a destination and where you are at the moment, you want to know what are the 3 best routes, for example, between Quezon City and Makati. And Waze can supply the top 3 routes. If you want to get there in 55 minutes, you can pass by EDSA, but there are 3 cops along the way. If you're willing to take an extra 10 minutes, you can go via the side roads. There are less police, but there are more accidents. So it's completely up to you whether you prefer to err on the side of more police or more accidents. And that's the essence of prescriptive analysis. You want to know the costs and the benefits of a decision. So how would a finance department use these types of analytics? So one of the easiest ways of using analytics is in reporting financial results. And that's an example of descriptive analysis. You're basically gathering all of the financial inputs from various parts of the company, putting it together, cleansing it, and reporting it for regulatory reasons or for management reasons. And that's the essence of descriptive analysis. You can also use the data to predict. So an example of predicting in finance is forecasting what the trend of the sales will be given the next few months. Maybe there were historical patterns of seasonality. Maybe we invested a lot in new salespeople, and that might also drive the sales trend in the next few months. Prescriptive is more about determining the feasibility of a project. If you have all of these various inputs into a project feasibility, for example, the cost of the materials, the location of the project, who your counterparties are, and based on your past experience, the prescriptive model can tell you what is the likelihood that this project will be delivered on time, on cost, without delay, Or the other way around, what is the likelihood that this project will fail, will overshoot the budget, or will actually cause you a lot of headaches? So these are 3 examples in a finance department of using descriptive, predictive, and prescriptive analysis. In human resources, analytics has a lot of applications as well. From a diversity perspective, an HR manager might want to understand, where do all my employees come from? Which schools? Which locations? Which addresses? Which demographics? And this is a good way of using descriptive analysis. Just looking at population counts, just looking at concentrations, and that might give you an idea of how to manage your human resources better. One area of concern in HR is figuring out which employees are likely to resign, because this means additional cost for the company in terms of recruiting new people. And predictive analytics can look at historical patterns of resignations and determine what are the likely causes of resignations and how many will likely resign in the future. This can also help in decision making, minimizing the costs for those people that resign and maximizing the loyalty of the people that stay behind. And lastly, for prescriptive analytics, HR managers can understand what are the drivers that makes employees happy and content. And employee engagement is one of the best areas to employ prescriptive analytics. Does it help to do Christmas parties? Does it help to do out-of-town events? These are all costs for the company. But if it means employees are generally happier, more productive, and will tend to stay longer in the company, that might be a worthy investment. So in HR, there is use for descriptive, predictive, and prescriptive analytics. And lastly, in marketing, probably one of the first areas where analytics has been employed, there's also applications. For example, just monitoring the results of a marketing and sales campaign, just tracking how many people received the offer, how many people clicked on the offer, how many people actually bought the product and paid for the product. These are all very valuable insights, and these are all possible using descriptive analytics. Or you might want to understand, what are the drivers that make a successful campaign? Do I want to spend on this marketing channel? Do I want to spend on that advertisement? Do I want to spend on these salespeople? So just understanding your marketing mix and attributing the effect. Okay, for this particular campaign, it's actually price that drove the performance. Whereas for that marketing campaign, it's actually the channels that drove the performance. Understanding how all of these factors contribute to the performance can help in predicting future performance or even hitting certain thresholds or certain targets. And lastly, prescriptive analytics has had a lot of application in marketing through recommendation engines. Those of you who have experienced buying something from websites like eBay and Amazon might have experienced an offer that goes like this. Those people who bought that book also bought this book, so you might really want to buy this book. And this is based on prescriptive algorithms, looking at patterns of people who buy the same product, or profiles that look similar, or items that are purchased together. These are all forming parts of what's called a recommendation engine, and it's been quite successful in driving more sales. If people see past patterns of similar products being bought together, there's a higher likelihood that they will actually follow the recommendation. So, to summarize what we learned today, first we reviewed how does data become value from raw data that's extracted and warehoused and curated and then prepared for analysis that then drives business action. Then we reviewed the 3 different types of analytics: descriptive analytics, predictive analytics, and prescriptive analytics. And then finally we reviewed how do these 3 types of analytics are employed in finance, in human resources, in marketing, 3 departments that are common in nearly every company. So I hope you enjoyed that. Thank you very much.
So okay, so this time I'll just want to show you a video presentation on how business analytics applied in a Shopee applications, no?
E-commerce may seem fast-free and seamless on the surface, but there's a lot that goes into its operations behind the scenes. Hi, my name is Pei Zi, and I'm a CLT trainee working as a full-time business analyst in Shopee. When you think of roles in tech-based companies, you'd often think of engineers and programmers, but the majority of functions in companies like Shopee are hybrid roles. And my role here is to streamline and facilitate the use of data by various teams through Salesforce. So with a role like this, it's beneficial to have on-the-job training and exposure through IMDA and Shopee's company-led training program.
E-commerce is a very dynamic and fast-growing industry. So it's important to possess good problem-solving skills and a deep understanding of the business in order to come up with the right solutions for each challenge. When I first met Pei Zi, it was the first day of circuit breaker. We couldn't meet face-to-face, but she was proactive and eager to learn. We found other ways to connect through weekly check-ins and eventually meals together. Her performance has been outstanding, and now she's leading her own projects ahead of schedule.
As a fresh grad, I had so many questions, but I soon learned that there are no fixed answers. So thankfully, Clara was there to help me navigate through each puzzle. The program has been meaningful to me not just because I've developed my skill sets, but also because I get to see the real-world impact of the work that we do. I took a leap of faith to join the tech industry, and I'm grateful I've had the TESA CLT program aid my transition into this tech career.
Okay, so it's just not only with Shopee, but even in aviation, it is also important to understand that an IT practitioner could able to work in an aviation company.
There are many ways that the aviation industry can use business analytics to automate its operations, reduce costs, and increase customer satisfaction. In this video, we will discuss a few real-world examples. Let's start by looking at examples of how aviation operations are changing digitally. When we say digital transformation, it is defined as the integration of computer-based technologies into an organization's products, processes, and strategies. Here are some of them. Automated messaging using chatbots. A chatbot is a program that is capable of simulating and processing human conversation through speech or the written word, which gives the impression that we are interacting with a real person. There are three types of airline chatbots in use today. First, intelligent chatbots. They use machine learning to recognize various user requests and provide customized replies. Over time, they adapt to provide better responses based on the user's questions. Second, rule-based chatbots. They are used to answer very specific questions with predefined answers. Examples are the chatbots used for providing customers with an interactive experience when it comes to frequently asked questions. Third, AI-based chatbots. They employ a combination of machine learning, natural language processing, and other subsets of artificial intelligence to solve user problems. They can remember user preferences and the context of conversations to provide a human-like experience. Cebu Pacific, the Philippines' largest carrier, introduced in January 2019 the all-around online travel assistant, Charlie, to guide and assist customers in their journey with the airline. Charlie is online 24/7, which can be messaged via the Cebu Pacific website or through the carrier's official Facebook page. He can assist in checking in for flights, provide the itinerary or boarding passes, and answer frequently asked questions about booking and the requirements needed before the flight. In-airport self-service. An increasing number of airports are already investing in automated border control, self-service check-in, and bag drop solutions that increase speed and efficiency while maintaining high levels of security. Fly2Gate by Thales, for example, makes traveling simple and more efficient by leveraging state-of-the-art technology required by the airport, airline, and immigration systems. Fly2Gate supports multimodal biometric checking and robust document verification. Baggage tracking. Delta Airlines developed an application for baggage tracking. Delta Airlines passengers can track their checked-in baggage through the airline's mobile app. Passengers who have downloaded the app simply have to enter the number on their baggage receipt or scan the barcode, and they will be provided with an update on the location of their bag. The app also tells the user which carousel to collect the bag from upon arrival at the destination airport. Self-driving or autonomous vehicles are equipped with numerous cameras and complex machine learning algorithms to interpret road conditions in real time and react accordingly. In 2009, Google started a self-driving car project with the goal of driving autonomously over 10 uninterrupted 100-mile routes. In 2016, Waymo, an autonomous driving technology company, became a subsidiary of Alphabet, and Google's self-driving project became Waymo. Carriers deploy predictive maintenance solutions to better manage data from aircraft health monitoring sensors. This grants the technicians access to real-time and historical data from any location. Knowing an aircraft's current technical condition through alerts, notifications, and reports, employees can spot issues pointing at possible malfunction and replace parts proactively. Past flight data is useful for identifying and assessing the impact of options for seat availability, new fares, new routes, and new flight schedules. Along with offering new flight schedules, flight crew members' availability and schedules should also be considered. Flight scheduling software is integrated to address this concern. This software adjusts the fatigue risk that flight crew members are in danger of due to the constant changes in time zones. Analytics applications help businesses understand their customers individually, their preferences, their behavioral patterns, and predict the requests that might come up. Airlines learn about the pain points of airport and flight experience of customers with the help of feedback analysis and sentiment analysis. Feedback analysis involves identifying the needs and frustrations of customers so that businesses can improve customer satisfaction and reduce customers unsubscribing to its services. Sentiment analysis, also known as opinion mining, on the other hand, applies a mix of statistics, natural language processing, and machine learning to identify and extract subjective information from text files, or the audience's opinion on a target object. With the help of these analyses in a predictive analytics application, the business keeps its customers up to date in real time and promotes special offers based on their needs, habits, and unique experiences. It also enables the business to make informed decisions and meet customers' expectations. When customers are satisfied and their preferences are understood, they tend to share their experiences with friends and family, which could lead to an increase in business revenue. With predictive analytics, the aviation industry can target customers with personalized offers while optimizing the price. The target customers become the target market. To define formally, when we say target market, it is a group of people with some shared characteristics that a company has identified as potential customers for its products. As a result, by gathering meaningful data, airlines can bring more bookings in the given time frame. To improve revenue, costs should be carefully managed. In the following examples, we can see how business analytics helps in reducing costs. Predictive analytics with built-in machine learning algorithms can collect and analyze data regarding each route's distance and altitudes, aircraft type, weight, weather, etc. Based on findings from data, systems estimate the optimal amount of fuel needed for a flight. Southwest, one of the major airlines of the United States and the world's largest low-cost carrier, signed a contract with GE Aviation to use its flight analytics system to improve fuel consumption for its fleet of Boeing 737s. Airlines are required to compensate passengers if their bags are damaged, delayed, or lost. This is an expense that can be avoided using real-time baggage tracking systems. Predictive analytics can use past data to predict the amount of food it has to offer for a specific flight. This will avoid throwing away a lot of food that is not consumed or purchased in the flight. The analytics considers multiple parameters such as weather, time of year, and the types of customers that are flying. Business analytics helps identify potential revenue leakage cases and take preventive measures. Revenue leakage in airlines is the mismatch between the expected revenue from the bookings that were made and the amount the airlines eventually receive. Identifying the areas of your revenue loss will enable you to minimize them. Many fraudulent methods can result in airlines incurring costs or suffering a loss of revenue. This is brought about by passengers paying with stolen cards, claiming reimbursement for fake lost baggage, and creating fake online travel agencies. To address this problem, airlines enhance customer authentication and payment security and implement advanced machine learning-based analytics software to process data from multiple sources and detect fraudulent transactions. We come to the end of this video lesson. I hope this video has given you some insight into business analytics in the aviation industry. If you find this helpful, please like and leave a comment. Please consider subscribing to my channel.
Okay, so this will be the last. No, actually, we have a lot of business analytics applications, but this will be the last. No, for the healthcare. No, as our example for the business analytics application. This will be the application of healthcare analytics.
In healthcare, large amounts of heterogeneous medical data have become available in various healthcare organizations. This data could be an enabling resource for deriving insights for improving care delivery and reducing waste. The enormity and complexity of these datasets present great challenges in analyses and subsequent applications to a practical clinical environment. In this series of lectures, we will explore the intersection of healthcare and big data. At the end of this lecture, you should develop understanding of healthcare data, the different analytics algorithms, and understanding the big data systems. The healthcare industry is huge, and there are a lot of data coming out of healthcare. The United States healthcare is incredibly expensive. Overall spending is $3.8 trillion in US per year. That's more than the value of 10 biggest companies plus 10 Beijing Olympics plus a Warren Buffett and a Bill Gates. But does it have to be that way? There is massive waste in healthcare, unfortunately. The estimated waste in US healthcare alone is $765 billion. That's equivalent to the NASA's total budget for the past 50 years. Not only the cost is an issue, but also the quality of healthcare is poor. There are 200 to 400,000 preventable deaths per year in the US. That's 1,000 people per day. If we classify the preventable deaths against other causes of deaths, it will be the number 3 causes of deaths in the United States, after only heart disease and cancer. So, there are massive problems presented in modern healthcare, including high costs, high waste, and low quality. How can big data help? The hope is big data can lead to better care and lower cost. In big data, people talk about the 4 V's. Volume. Healthcare generates a large volume of data. For example, for genomic data, each human genome requires 200 gigabytes of raw data or 125 megabytes if we store just SNPs. For medical imaging data, a single MRI is about 300 gigabytes. Medical imaging data generated in the US per year was estimated to be 100 petabyte. Variety. Healthcare also generates a lot of different kind of information, such as clinical information, including patients' demographics, diagnosis, procedure, medication, lab results, and the clinical notes. Patient also generated a lot of data, such as information coming out of arm body sensors and other devices that patients wear. Velocity. Healthcare also generate a lot of real-time data, such as blood pressure measures, temperature, heart rate, drug dispensing levels at intensive care units. Veracity. Unfortunately, healthcare data often comes with a lot of noise, a lot of missing data, a lot of errors, and a lot of false alarms. It is a big challenge in healthcare data analytics. While the landscape is changing for healthcare big data analytics, as more organizations figure out how to harness big data and implement the right infrastructure for generating actionable insights from a slew of new sources, some providers may still be wondering how big data can actually work for them. Luckily, a number of pioneering organizations have taken it upon themselves to test the waters of healthcare analytics, generating use cases that spur interest and help carve a path through the wilderness. In the following sections, we will explore some of the ways healthcare organizations have already found success by turning big data into a strategic asset that can help providers react quickly and effectively to the ongoing challenges of quality care delivery. One way big data could revolutionize healthcare is by improving hospital quality and patient safety in the intensive care units. The ICU is an area where big data analytics is becoming crucial for patient safety and quality care. The most vulnerable patients are prone to sudden downturns due to infection, sepsis, and other crisis events which are often difficult for busy staff to predict. However, a number of organizations have been working on integrating bedside medical device data into sensitive algorithms that detect plummeting vital signs hours before humans have a clue. At the University of California, Davis, researchers are using routinely collected EHR data as the fodder for an algorithm that gives clinicians an early warning about sepsis, which has a 40% mortality rate and is difficult to detect until it's too late. Finding a precise and quick way to determine which patients are at high risk of developing the disease is critically important. At Massachusetts General Hospital, an analytics system called QPID is helping providers ensure that they don't miss critical patient data during admission and treatment. The system is also used to predict surgical risk, helping match patients with the right course of action that will keep them safest during their care. The last thing a doctor wants to do is do harm to a patient or do something inappropriately. The system automates searches using national guidelines, and then it essentially shows the results in a dashboard with a red, yellow, or green risk indicator for the surgeon to see. Another area where healthcare analytics may make a significant impact is in precision medicine and personalized care. Precision medicine entered the healthcare industry's lexicon in a big way in recent years during President Obama's State of the Union address in 2015. The president's vision for a nationwide patient databank sparked hopes of a renewed commitment to genomic research and the development of personalized treatments. But the NIH isn't the only one who has been using big data to predict the course of diseases related to a patient's genetic makeup. Healthcare predictive analytics has been particularly instrumental in the fight against cancer, and has also helped to target the development of preventative measures related to heart disease, diabetes, and even food poisoning based on genetic research. Population health management is as much about prevention as it is about treatment, and healthcare big data analytics equip providers with the tools they need to be proactive about their patients' needs. Targeting patients based on their past behaviors can help to predict future events, such as a diabetic ending up in the emergency room because he did not refill his medication, or a child with asthma requiring a hospital admission due to environmental triggers of her disease. By harnessing EHR data, providers can even identify links between previously disparate diseases. A risk score developed by Kaiser Permanente researchers in 2013 allows clinicians to predict diabetic patients who are likely to develop dementia in the future, while the Army is attempting to curb the rampant rate of veteran suicides by leveraging a predictive risk model to identify patients who may be likely to harm themselves. Healthcare predictive analytics can even prevent bottlenecks in the urgent care department or emergency room by analyzing patient flow during peak times to give providers the chance to schedule extra staff or make other arrangements for access to care. Emergency department crowding is a complex problem affecting more than 130 million patient visits per year in the U.S. In the current world of scarce resources and little margin for error, it is essential to rigorously identify the specific causes of crowding, so that targeted management interventions can have maximal effect. Finally, as hospitals begin to feel the financial pinch, they are turning to healthcare analytics to keep patients at home. At the University of Pennsylvania, informaticists can look at prior hospitalization histories to flag patients who may be returning to the inpatient setting within 30 days. Real-time EHR data analytics also helped a Texas hospital cut readmissions by 5% by drawing on nearly 30 data elements included in the patient's chart. This is one of the first prospective studies to demonstrate how detailed data in EHRs can be used in real time to automatically identify and target patients at the highest risk of readmission early in their initial hospitalization, when there is a lot that can be done to improve and coordinate their care, so patients will do well when they leave the hospital. Meanwhile, the Kaiser Permanente system has been working to refine its readmissions algorithms in order to better understand which returns to the hospital are preventable and which are not, a crucial distinction for value-based reimbursements. Classifying readmissions as potentially preventable or not preventable can be used to improve hospital performance. Administrators can sort potentially preventable readmissions into categories that are actionable for improvement. They can identify trends over time or across reporting units. Classifying readmissions as potentially preventable or not preventable can also be used to establish accountability across reporting units and reward top performers. In summary, healthcare analytics are not some future fantasies, but are already happening in the real world and disrupting clinical routines and practices. As new technologies emerge and consumer demand for control over personal well-being increases, it will be ever more important to understand how best to navigate the large collections of data for healthcare organizations, and how to scale your data to keep it relevant.
Okay. So again, information technology is now pervasive in society. No? For example, cell phones, sensors, retail scanners, and the internal generate massive amounts of data that are of potential value for business. So we truly live in the age of data, and the amount collected will only continue to grow. So the information available is only valuable if it can be converted into insights. No? So across all industries, opportunities for business analysts have exploded as major organizations have adopted data-driven and technology-focused approaches. Demand based on the estimates from the Bureau of Labor Statistics will only increase between 2018 and 2028. So we need management analysts, operation research analysts, market research analysts, financial analysts. Beyond these roles, other example of business analytics careers at today's leading employers include management analyst or consultant, data analyst or scientist, business intelligence analyst, program and marketing managers, big data analyst specialist or big data analytics specialist, research analyst, manager of services or manufacturing operations, business intelligence, and performance management consultant, pricing and revenue optimization analyst. Because all types of organizations are now harnessing the power of big data. Several industries need business analytics professionals, including healthcare, marketing, logistics, e-commerce, finance, food service and restaurants, entertainment, professional sports, and even casinos. Now, currently, 85% of the positions in business analytics required an advanced degree, with 75% specifying business analytics tracks as an educational requirement. So to prepare for these careers, we need, of course, to enroll not only in the undergraduate program, but even in a master's degree program. Now, I just want also to say that the discussions emphasize different real-world applications of business analytics on a daily basis. Also, in the application, the role of business analyst is described with significant illustration. Business analytics works in different domains and offers multiple applications related to the domains such as stock and bond market, healthcare, as I mentioned, and even agricultural growth, financing, marketing, and others. Business analyst seeks business interrogations to avoid regular trends in the market. It uses his skills, knowledge, technologies, and practices in finding business problems, business insights, planning, and performing various functions within a business. So I think that's it for Module 3 and Module 4.